Hello everyone. Note down this question. There are two beakers with base areas A1 and A2. And both these beakers have same height of water column inside them. Force at the bottom, the first is F1 and the second is F2. Pressure at the bottom is P1, P2. Force due to this water column at the bottom is F1. Force due to water column there at the bottom is F2. And pressures are P1 and P2. Then find out which option is correct. Consider them A, B, C, A, B, C. If you think this is A, then write down AA. If you think AB, then write down AB, and like that. Write down your answer in the comment box. Good. Everybody has answered correctly. Everybody can see that there is more mass present in this beaker. M1, M2. More liquid is present. That means M1 is greater than M2. So what is F1? F1 is nothing but weight of the liquid. This beaker is holding the entire weight of the liquid and therefore M1G, and F2 is what? M2G. Since M1 is greater than M2, correct answer is what? A. And as far as pressure is concerned, this P1, it is what? What is the formula for pressure? H rho G. H rho G. What is P2? Same height, same liquid, H rho G. That means P1 is equal to what? P2. Now note down this. Now the beaker is in this shape. And you have the liquid inside. height from the bottom is h. Another beaker in this form, same height of the liquid. This height is again what, h. And we have been given that they both have same base area A. It doesn't look same, but remember they both have what? Same base area, AA. Again answer this thing, relation between F1 and F2. What is F1? Force exerted by the liquid at the base of the beaker. Force exerted by the beaker at the base, and P1 and P2. What is the relationship between P1 and P2 and F1 and F2 in this case? Same base area. Look at the shape, P1 and P2. Good. Almost everybody is correct. What is the shape? We don't have to worry about that. Pressure is still what? H rho g, where h is what? Vertical height, which is same. And therefore P1 is equal to P2. P1 equals what? P2. Now, what is force? The force will be coming like this. Force is coming like this. The entire liquid is pressing the base down with the force of F2. But what is force? Pressure into area. You've got same pressure, you've got same area, and therefore F1 is what? F2. They both have same force. Note down this. Can you see this? This is N1 mass of liquid in this, and this is N2. Well, tell me, is it same? The force is coming same. Is N1 equal to N2? Yes or no? Fast. The liquid in both these beakers, remember they have same base area. Is mass of liquid in this and mass of liquid in this Are they same or no? What do you think? Good. If you have same base area, you can see that this thing will have much more liquid than this one with narrower cross-sectional area at the bottom, at the top. You can easily fill this and get to the same height as compared to this one. You need more liquid for this particular one, and therefore N1 is greater than N2. But although this has more mass, you're getting same force at the bottom. Reason, same height, that gives you same pressure, and once you have the idea of pressure, you can find force directly. That's the reason we are interested in pressure first and then force. Now who can tell me, although this has more weight in it, but still force at the base, at the bottom of the beaker is coming same. This has more weight, still you are getting same force. How is it possible? Can you give me an idea? If you think you can give me an idea of this, then mention that in the comment box. But let's say, because of normal reactions coming from the side, these side walls, they are also supporting the liquid in this case. Whereas in this case, what is happening? Look at the free body diagram and it will be more clear. If we draw the free body diagrams of the first one, free body diagram of the liquid inside. This is the shape of the liquid. Liquid was exerting a downward force. The bottom is exerting that force up. This was F1. Weight of the liquid is mg. But in this case, F1 is not mg. The side walls, they are also providing a force coming from these sides. Let's call it F1 dash, because F2 will use for this one, and therefore let's call it F1 dash. This is also F1 dash. So the liquid which you have is getting a support from this side, support from this side. Vertical components of F1 dash, let's call them F1 double dash. We are into the concept only, we are not interested in angle and all. If you say that the vertical component of F1 dash is F1 double dash, then for the first one, weight mg is being balanced by F1 as well as 2F1 double dash. This and this, all three are supporting weight of the liquid. Whereas if you consider the second case, this, and this is the shape. This is the shape. mg, weight is coming down, force was F2, Now, normal reaction force is acting towards the body. These side walls are pushing this liquid in this direction with a force of F2 dash. That's your F2 dash. Similarly, a force is coming from this side, which is also F2 dash. And then, if you take the vertical components, let's call them F2 double dash and F2 double dash. I'm not showing you horizontal components because horizontal components will simply cancel out each other. Now, for this liquid, you can see that Mg, this and this, they are balanced by force of F2. So for this one, F2 is balancing Mg, which is the weight of the liquid, plus F2 double dash. F2 has to balance Mg and these two components. Just so that you understand the free body diagrams, I have drawn these things. And in our question, we have, for this particular question, we have same value of F1 and F2, same value of F1 and F2. These are same. And that gives you an idea what basically is happening in the whole setup. Draw these free body diagrams also. Which means let's try a last profile of this type. If I give you something like this, try to answer the question as fast as you can. We have two beakers, same cross sectional, same base area. And in these, we have filled same amount of water. They have same cross sectional area. Cross section means base area is same. You're filling them with same amount of water. Find out relationship between F1 and P1. F1, F2 and P1, P2. Same amount of water. Nothing is given about height and all. They have been given that mass of water is same. They have same cross-sectional base area. What is the relation between F1, F2 and P1, P2? Try to answer both parts. trying to answer both parts, F1, F2 and P1, P2. Now, how easy it is to answer the question depends how you visualize the setup. I asked you to fill these beakers with same amount of water. That means something like this is going to happen. I hope you all can see that. This is H1 vertical height and this will be H2. पूरी कहानी अब केवल इस पर टिकी हुई है. Do you understand that H1 will be less than H2 if you are filling them with same amount of water? Do you understand this part, yes or no? Those of you who could not answer or the answer is not correct, you can take a hint from this. If you have same base area and as you go up, cross section increases, then height of the liquid column will be less as compared to this situation. If you have a bottle which is tapering down like this, as you go up, you can easily fill this bottle. Now, the moment you visualize that H1 is less than H2, everything is done. What is P1? P1 is H rho G. H1. What is P2? H2 rho G. But H1 is less than H2. ये कहाँ से आ रहा है? Simple feeling, and therefore P1 is less than P2. What about F1 and F2? What is force? Force is pressure into area. Force is pressure into area. We are dealing with force at the bottom only, at the bottom of the beaker only. Now you have same base area, but P1 you are saying is less than P2, and therefore F1 is less than F2, P1 is less than P2, because H1 is less than H2 and your mass is what? Same. Now you can also understand this F1 less than F2 by using simple logic. In this case, let me do that in this figure only. Free body diagram of the liquid. Remember, I am drawing the free body diagram of the liquid. F1 is coming from this side and two forces are supporting from this side, F1 dash, F1 dash. F2 is coming from this side and two forces are coming from the sides. Like this. So, they both have same weight, same mass. In this case, F1 is being supported by these two. You all can see you're getting a support from the side. So you have to apply less efforts. इस F1 के साथ साथ ये दोनों अपने vertical component से mg को संभाल रहे थे. What about this figure? In this, F2 has to deal with weight of the liquid as well as down thrust coming from the sides. So F2 is taking care of mg and the down thrust, and therefore definitely it should be more. And if you understand the visualization and everything, then write down yes in the comment box and note down this. We have two beakers as shown in the figure, larger base, smaller base, and different heights. Let, let's have the easy one first. This has more height, less. And then what we did, we connected them with a tube near the bottom. They are connected and water can run through this tube. It can easily move through this blue tube at the bottom. This is beaker 1, this is beaker 2. This has more water. You can see it's a very large tank. Large tank. Just a bottle. You connect them with a tube. Then flow of water will be from 1 to 2, 2 to 1, or no flow. Same things can be asked in this form also. Pressure का idea, वही चीज यहाँ पर. Let's see how many of you can answer this. What will be the direction of water flow? Good. Almost everybody has answered correctly. It has nothing to do with amount of water. Nothing to do with amount of water. Everything is based on what? Pressure. You're moving things with the help of what? Pressure. In this case, this is the height. You have more pressure, P2, you can see H2 rho G. In this case, you have less height, pressure is less at this place. You have less pressure, you have more pressure, and therefore liquid will move like this. From the thinner tube into this larger टैंक. यहाँ लिक्विड कम है, यहाँ पानी कम है अपने पास, लेकिन फिर भी इससे इसको आप क्या कर सकते हो? फिल. Now, second part of this question. Now, as this water runs through this blue tube, ultimately an equilibrium will arise. Once that equilibrium arises, in which tank there will be height of liquid column will be more. Once all this water which can flow, all that water which can flow has flown, and ultimately we arrive at an equilibrium. After the equilibrium is reached, in which column, in which tank, there will be greater height of liquid column. Good. Once you say that equilibrium is present, if equilibrium is present, I'll show that with the help of this red color. Once equilibrium is present, situation will be like this. It has gone up and it has come down. Since water is moving from this to this is going up, this is coming down, and ultimately they both, I hope you can see this, the red color, they both will acquire same height. So final height will be same. At equilibrium. Now this gives us a very interesting advantage. What is that advantage? Look here. Let's take a U tube in this form. It has larger cross section at one place and is thinner at the other. The other limb is thinner and that one is thicker one. And they are both connected at the bottom. Now, there is some liquid present inside. And this liquid is also under some force F1. This is also under a force F2. F1 and F2. A1, A2. You all can see that A1 is greater than what? A2. This is a liquid. You have capped the top surface, and then you are pushing the whole thing with the force of F1. In here, you're also pushing the whole thing with the force of F2. Now, once the whole thing settles, you started pushing them and ultimately एक इक्विलिब्रियम स्टैब्लिश हो गया. जब वो स्टैब्लिश हो जाएगा इक्विलिब्रियम, तो हम क्या नोटिस करेंगे, उस पार्ट को समझो. Just imagine, and this is a very useful technique. Suppose this portion has a blue shaped spatial liquid volume. कुछ स्पेशल नहीं है, अपन ने क्या किया हुआ एक imaginary portion. If you remember the previous lecture, I told you to imagine things like this, like in this whole space. If I asked you to imagine what a cube, I asked you to imagine a cylinder. Similarly, right at the bottom, I asked you to imagine a cylindrical volume. The whole cylindrical volume is nothing special. It's the cylindrical water which is present in this region. Once equilibrium arrives, I have no idea what is this height, I have no idea what is this height. Once that equilibrium arises, pressure coming from this side is P2, pressure coming from this side is P1. अपने को नहीं पता कि ये हाइट इससे ज्यादा है या कम है, ज्यादा भी हो सकती है जैसा दिख रहा है इसमें अभी, कम भी हो सकती है, इक्वल भी हो सकती है, we have no idea. But once equilibrium arrives, we are sure that P1 should be P2. Now, without my help, let's see how many of you are comfortable with this. Whatever be the forces F1 and F2, height of liquid column in these limbs, but at equilibrium, pressure coming from this side and pressure coming from this side, they should be equal. Are you comfortable with this? Yes or no? And then I will prove it. But let's see how many of you can feel it. Good. Some of you are saying no, they are not able to feel it. Don't worry. अपन फील करवाएंगे. कैसे फील करते हैं देखना. Look at this blue portion. This blue portion. Say this blue portion has a cross-sectional area of A on both sides. This is A1, which is greater than A2. What is A? Cross-sectional area of this blue imaginary or hypothetical volume which you have considered. Now this is being pushed from this side as well as from this side. The force coming from this side is F1 dash, not F2 dash. This is F2. The force coming from this side, I have given it a new name, F2 dash. This is F2, force coming from this side is F2 dash. Similarly, this is F1, and the force coming from this side is what? F1 dash. F1 dash. This is F1, this is F2. मुझे आइडिया नहीं है कि इसके अंदर क्या रिलेशन है, लेकिन मुझे पता है कि ये F1 डैश और ये F2 डैश क्या है, सेम. क्यों? Let's say its mass is m, its acceleration is a, but a is 0. Why? Because system is in equilibrium. यानी क्या बोला था, पूरा सिस्टम किस पे सेट हो गया है, इक्विलिब्रियम में. अगर इक्विलिब्रियम है, फोर्स कमिंग फ्रॉम दिस साइड, फोर्स कमिंग फ्रॉम दिस साइड, they are F1 dash and F2 dash. What is F? Mass into acceleration. What is force? F1 dash minus F2 dash. But what is the acceleration? 0. And therefore F1 dash will be F2 dash. पता नहीं क्या प्रूफ कर दिया है, फिर से हमने प्रूफ कर दिया है कि एक गिवन डेप्थ पर अगर इक्विलिब्रियम है तो ऊपर क्या हो रहा है डजंट मैटर. एट दैट गिवन डेप्थ योर प्रेशर and force will be same. If you have an equilibrium like this whole thing is connected to this. When equilibrium is present, both sides are being pushed by same force or same pressure. क्या यूज किया? F equals to ma, laws of motion. F1 dash equals to F2 dash, and this is something which is very interesting. कैसे है, थोड़ी देर में आपको फीलिंग आ जाएगी, but those of you who said no, I hope they understand how come P1 is P2 and F1 is F2. Once I say force is same, they have same cross-sectional area, divide this thing by A, divide this thing by A, and you will get what? P1 equals to P2. इसका फायदा क्या उठाएंगे वहां भी जाएंगे, पहले इतना नोट कर लीजिएगा. Write down a statement. I will call it a continuous system. The whole thing is connected to this left limb is connected to the right limb, not like the previous profiles when you had separate beakers. If you have a continuous setup like this, for that continuous setup, we are writing the statement. So mention this: for a continuous setup, at equilibrium, pressure at a given depth everywhere will be same. Pressure at a given depth everywhere will be same. It should be a continuous one, should be at equilibrium. Now this is the generalized situation. Now इसको थोड़ा सा एक special case में convert कर दें, which you can easily feel and relate to also. And remember, we'll be using this technique in next questions. That's all the same tube type of thing. There are two U tubes. Now we have been given that we have kept same height of water. This is H. This is H. A force is pushing this side down with F1. A force is pushing this side down with F2. This is A1. This is A2. Find out if F2 in terms of F1. F2 in terms of F1 using A1 and A2, using this concept. What is the concept? ऊपर क्या है पता नहीं, बॉटम पर जो भी प्रेशर होगा इक्विलिब्रियम में कंटिन्यूअस बॉडी में दैट विल बी सेम, क्योंकि अगर सेम नहीं होगा तो फिर ये मूव करेगा, और अगर ये मूव करेगा इसका मतलब इक्विलिब्रियम नहीं है। चीज कब तक मूव करती है? जब तक इक्विलिब्रियम नहीं आ जाता। इसका मतलब अल्टीमेटली कभी ना कभी इक्विलिब्रियम आएगा ही आएगा, और जब वो आएगा तो फिर दोनों तरफ से फोर्स एंड प्रेशर क्या हो जाएगा? सेम। So that equilibrium is there. What is the relationship between F1 and F2? That's what I'm asking you. Should not take more than 30 seconds. Let's see if you can. Well, some of you have answered this thing. Look here. What is pressure? Let's find out pressure at this place. Let's call it P1. Pressure at this place, call it P2. You know that P1 is P2. पता है अपने को कि P1 P2 होगा, ऊपर क्या हाइट है अपने को मतलब नहीं उससे। So this is P1, this is P2. What is P1? This P1 has to take force coming from this water column as well as F1. This P1 is what? Force of this plus this divided by the cross-sectional area. So what is P1 at this place? H rho G plus pressure due to F1. What is that? F1 upon A1. कुछ इस तरह की चीज. If you remember the last class, we had a beaker filled with water, and then I told you that this system is nothing but a block of mass m. Liquid inside is equivalent to this. Now, if somebody starts pushing this thing down, it's like you're also pushing this block down. In that case, your normal reaction has to balance weight of m as well as this force. So that's what is happening. यहाँ का प्रेशर क्या होगा? H rho G plus F1 नहीं, F1 divided by A1. इस F1 को यहाँ पर प्रेशर में कन्वर्ट कर दिया F by A, which is equal to H rho G plus F2 divided by A2. These heights are same. If they are same, we have got the relation, and the relation is F2 equals to H cancel, F2 is coming, A2 divided by A1 multiplied by F1. F2 is A2 divided by A1 multiplied by F1. क्यों हमने ये कॉन्सेप्ट डेवलप किया? यहां देखना. Look, you have a tube type setup. This side is large, this is thin. Right at this place, you have a car of 1000 kg, 1 ton. Question is, by using what force we can balance this car if cross-sectional area of this side is 1 meter square and cross-sectional area of this side is 1 centimeter square. Answer the question. You have a car of 1 ton on the left side which has a cross-sectional area of 1 meter square. You cannot basically place a car of 1 ton over a 1 meter square area. So somehow you made an arrangement. You could do that. On this side, you have a very thin tube of only 1 centimeter square, roughly this much, this much, this much. So with what force you can balance this car? Answer this. Taking too long. Well, I'm asking you F2. What is F1? Its weight. So in this question, your F1 is 1 ton, which is 10 to the power 3 G mg. That's 1 ton. Don't forget to use this G. If you simply write 10 to the power 3, kahani gadbad. 1 ton is 1000 kg multiplied by G. This F is basically F2. What is F2? A2 upon A1. A2, 1 centimeter square is 10 to the power minus 4. Centimeter into centimeter, 10 to the power minus 2 into 10 to the power minus 2 divided by A1. A1, which is 1, multiplied by F1, which is 10 to the power 4. Take G also as what? 10. The answer is coming what? 1. What? Newton. So F2 is what? 1 Newton. You know what 1 Newton is? 1 Newton is 100 grams. If you have a mass of 100 grams, then that is what? 0.1 kg multiplied by G. 0.1 into 10, 1. So can you see that? 100 grams, which is almost the weight of this marker. Or you can say 2 markers, max. These 2 markers can lift a car which weighs 1 ton. And I hope you have heard something like hydraulic brakes, hydraulic systems, hydraulic lines. This is that principle. Principle of hydraulics does the same thing. Just because you get same pressure, you can lift a very heavy object by using a very small amount of force. If you understand this concept of hydraulics, then write down yes in the comment box. One of you is saying that F1 is 10 to the power 3. No. Car 1 ton. What is ton? 10 to the power 3 Newton. No. 10 to the power 3 kg. 1000 kg. So this car, when I say it weighs 1 ton, it means its mass is 1 ton. Unit. Mass and its weight is what? mg. And therefore you need to multiply with g. That makes it what? 10 to the power 4. Which gives you 1 Newton as a force. So if they ask you what force should be applied, answer is what? 1 Newton. And if they ask you that how much weight should be placed, and options are in terms of mass. You will find this type of language set up most of the time that they are talking about weight, because in normal practice we say 1 kg weight, 5 kg weight. So when you say 5 kg weight, actual weight is 5 into g. So if they ask you what weight can lift this car over 1 ton, answer will be 100 grams weight. When I say 100 grams, it means 100 into g. 100 grams, that is 0.1 grams, 0.1 kg multiplied by g. So don't forget this conversion of mass into its weight. The answer is no force is present on this side. Both limbs have same cross-sectional area. Call it A and A. But what you are basically doing, if I remove the force, then in both limbs, height of liquid column will be what? Same. Now what we are doing, we are pushing the right side liquid down, and at a particular depth, this is H. The height difference in liquid column is H. I hope दिख रहा होगा यहाँ, और ये जो height difference है, this is H. Find out F so that you can maintain a height difference of H in both limbs. Density rho, cross-sectional area of the limbs is what? A. Very easy question, should not take more than 30 seconds. Let me repeat the question again. Initially, both limbs, as you would expect, will have same height, irrespective of cross-sectional area. Now, you decided to push this side down and ultimately created a height difference of H in both limbs. To do that, what amount of force is required? And the hint is you can answer the question in just 10 seconds if you wish. If you wish. It's so easy. कोई खतरनाक इक्वेशन बनाने की जरूरत नहीं है, हालांकि कोई इक्वेशन खतरनाक नहीं है. ऑलमोस्ट करेक्ट, थोड़ा सा रह गया, बिल्कुल सही हो जाएगा, ऑलमोस्ट करेक्ट। बाकी लोग, लेट्स नॉट वेस्ट टाइम, लुक हियर। अपने को क्या बोला गया था, दैट यूज डाउनवर्ड फोर्स व्हिच कैन क्रिएट अ हाई डिफरेंस ऑफ एच। बोला ठीक है, हमारे पास फोर्स नहीं है, रिमूव इट, remove this, and then do what? Fill this portion up to this height. If I fill this portion up to height h with same liquid, then what would you expect? ये भी रो, ये भी रो, आपने यहां भी क्या फिल कर दिया, रो, तो दोनों की हाइट क्या हो जाएगी, ऑटोमेटिकली सेम। फिर से सुनना, यहां पर एक आदमी फोर्स लगा रहा था, डाउनवर्ड फोर्स। Now, instead of that downward force, what you decided, you remove the force and you placed a liquid of height h, same liquid. Once you place this liquid of height h, अपनी कहानी क्या होती है, दोनों लिम्स में हाइट क्या होनी चाहिए थी, सेम। इसका मतलब the force which you are looking for is nothing but weight of this blue portion. Now how do you find weight? Volume into density is mass multiplied by g. What is the volume? Cross sectional area A, height h, rho g. Answer. In 10 seconds you can answer this. If you understand this shortcut, then write down yes. And only one person could answer this thing. But I hope you can see what an easy question is it. Always go for this type of visualization. उठा के फिल कर दिया, बंदा हो गया। Now look here. We have a beaker or a bucket filled with water, and then you decided to accelerate this bucket in this direction with acceleration A. Beaker filled with water, and you're accelerating the whole setup horizontally with A. What type of top surface you would expect? Type 1 or type 2? Answer this fast. A beaker filled with liquid. Pull it horizontally with an acceleration A. Top surface, it will be of type 1 or type 2. What do you think? बात सही, it is 2, it's not 1. How easy it is? Take a water bottle and pull it horizontally, and you can see that. It will be difficult for me to show you this thing, but in case you can, I hope, I don't see, maybe you can or cannot. If you can see the top level, see there is water inside, and if I pull this bottle horizontally, you have to look the very instant I give it a push. because ultimately I have to stop it. So once I stop it, basically I am giving the bottle an acceleration in this direction. Remember, if I start pulling it in this direction and then I have to stop it means acceleration in the opposite direction. So the very initial moment, look at that. If I pull this thing, do it yourself, and you will find that top surface is this. So this is something which is very easy. तो ऐसे ही पूछा था अपन ने. असली क्वेश्चन क्या है? Find out theta. That's the question. Easy में ये भी question है कि type 1 होगा या type 2 होगा. But the good question is, what is the angle which top surface makes with horizontal? I'll give you just 30-40 seconds to answer this if you can. And the hint is, use this technique of imaginary volume. हमने छोटा सा सिलेंडर टाइप का बनाया था. Make a U-tube sort of thing. Hint, if you can manage. Look here. This side. This is the top surface, and do what? Do this. Imagine this blue shaped portion. This is the left limb, right limb. Suppose this height is h1 and this height is h2. Now, at this place, which is this, at this place, pressure is P1. At this place, pressure is P2. Now we have written a statement. P1 is P2 greater than, less than. Which one is correct? A, B, C. Answer first. At the same horizontal level, pressure, it will be 1, 2, 3. Answer this thing fast. As fast as you can. Good, that's what I expected from you, that everybody is answering P1 equals to P2, but it is not. इसीलिए question दिया हुआ है. Look, that was what? And final steady state. Steady state में same horizontal level पर pressure क्या था? एक continuous body में same. ये steady state कहाँ है भाई? ये तो पूरा setup क्या है? Accelerated. This whole thing is accelerated in this direction, and therefore P1 equals to P2 is not correct. क्या आपको पता होना चाहिए था? This imaginary volume, look here, ऐसे black में ही show कर रहा हूं because it's easily visible. This portion is this, थोड़ा enlarge कर दिया है. A force is coming from this side, F1. A force is coming from this side, F2. Mass of this thing is m, and the whole thing is accelerated in this direction. Can you say that F1 is F2? No, you cannot. You have an accelerated system. So what would you say? you will say this, F1 minus F2 is mass into acceleration. And therefore, कहां पर force ज्यादा है? This side. अगर इस साइड फोर्स ज्यादा है तो प्रेशर भी क्या होगा? ज्यादा होगा. And therefore correct choice is what? B. Now let's complete the whole thing. बाद में देखेंगे कि और भी इजी था. पहले ही देख लो कितना इजी था. प्रेशर क्या होता है भाई? प्रेशर अपने को ये सिखाया गया है. क्या होता है? H रो G. इस जगह पर हाइट कितनी है? H1. P2 क्या होगा? H रो G. What is the height? H2. कहां की हाइट ज्यादा है? At this place. If height is more, pressure is also more. इतना easy था. फिर भी कोई नहीं. Look at this answer fast. So F1 equals to F2. It's not correct. F1 minus F2 is what? Mass into acceleration. What is F1? Pressure. What is pressure? H1 rho G. इस जगह पर कितनी हाइट है? H1. प्रेशर ये है और इसका क्रॉस सेक्शनल एरिया कितना है? टेक इट A into A minus H2 rho G into A. अब देखना रे इधर. What is mass? किसका mass? इसका mass. What is this? A cylinder. What is mass of a cylinder? Find out the volume first. A into L. What is L? Say its length. लेकिन ये तो दी नहीं थी, जरूरत भी नहीं होगी. क्यों नहीं होगी? देखना. A into L is the volume of this portion multiplied by density. Volume into density is what? Mass multiplied by A. Rho cancelled. A cancelled. What do you get? You get something like this. H1 minus H2 divided by L equals to A upon G. H1 minus H2 divided by L, take G this side, A upon G. Now, can you see what is H1 minus H2 upon L? This is H1, this is H2. Thing in red. This much in red. Up to this place. The whole thing is H1, this is H2. What is the red part? H1 minus H2. What is the bottom? L. And what about this angle? Theta. What is tan theta? Perpendicular upon base. Tan theta perpendicular upon base. Question is find out theta, and theta is coming tan inverse A divided by G. बड़ा इंटरेस्टिंग मस्त चीज. कैसे? Something which you can do yourself. Fill a bucket, half, pull it horizontally, and you can yourself decide what the angle top surface is going to make, and you can predict that using this much physics. ये physics क्या थी? ये physics थी force is pressure into area and force is mass into acceleration. यहां से पूरी की पूरी कहानी हमने क्या की हुई थी? डेवलप. If you understand this completely, then write down yes in the comment box and then you can leave. Thank you very much.